As we look to ensure that we're staying in line with the syllabus, I want to go over a couple high-level topics. In the previous virtual lecture, we focused on the select statement. Now, when we're looking at the select statement, we're really looking of how we are doing the mapping component of the select from where. As previously stated, when we're doing a select, we're going to essentially be pulling values from an attribute list, from a list of tables where certain conditions are met. So when I'm showing this, the attribute list is going to be the list of attribute names whose values are to be retrieved by that query. The table list is going to be a list of the relation names that are required to process the query, and the condition are the expressions that identify which rows or tuples are to be retrieved by the query. For example, if we were looking at a relational database schema for the next several queries, the next several slides are going to be walking through essentially employee data, department location data, project data, works on data, as well as dependent data. Sharing names from a first name perspective, a department number perspective, department location perspective, etc. Examples of that from a populated database perspective is as shown. You're seeing everything from John Smith with a Social Security number born in 1965 out of Houston, Texas, to the research department, to specific product and project names such as computerization with IDs and locations in Stafford, Houston, and Sugar Land. If we're going to use that data and write some simple queries, the first one that I want to look at would be retrieving the birth date and address of the employee whose name is John Smith. In this example, you will be selecting from the list of attributes the birth date and the address from the employee table, where the first name is John, middle initial is B, and last name is Smith. Very clean, very straightforward. From an exam perspective, you're going to see a copy of the SQL and be asked what it is trying to do. Next query, retrieve the name and address of all employees who work for the research department. So I'm specifically looking for name and address. The way this is set up, we're looking at both first name and last name, as well as address. So those are the items that I'm going to select. And as you can see, I'm looking for employee information and department information. Now, the employee name information is not in the department table, so I'm going to need to select both from the employee table as well as from the department table, with specific criteria where the department name is research and department number is DNO. Now, if we're continuing along those same lines, let's go with another example. For every project located in Stafford, I'm going to want the project number, the controlling department number, and the department manager's last name, address, and birth date. Some very specific attributes for this. So in this situation, I will be doing multiple attributes. So in this case, the project number, department number, last name, birth date, and address. And I'm pulling from 3 tables without using joins. So I'm pulling from project, department, and employee. Now what you're going to see in the conditions from a where perspective, I'm going to be pulling and tying different components together. So I want department number and manager social security number and social security number to match, as well as location equals Stafford. It's a little bit cleaner if I'm looking for a query that for each employee that I want to retrieve the name and the name of his immediate supervisor. So I'm pulling from both the employee table and the supervisor table, first name and last name, from the employee table where the supervisors and the employees' social security numbers match. Another example, if I want to make a list of all project numbers for projects that involve an employee whose last name is Smith, who's both a worker and a manager of the department that controls the project. Again, we're getting even more specific, and this is what you're going to see as you're looking at the types of queries and types of reports that will need to get run. So if I'm going from this perspective, I'm going to select a project name from both the project, department, and employee tables. Now, what I'm going to do is then do a union. So I'm looking at it from where the department number and manager numbers are equaling, and I'm unioning or adding this to and unioning this to the another from statement and another where statement. Now, we can also look at using wildcards and comparison operators like in if we're going to want to do a comparison of values. So if I want to retrieve the name of each employee who has a dependent with the same first name as the employee, I'll be selecting the first name and the last name from the employee where both the employee social security number and select social security number from the dependent are equal to the first name of both the employee and the dependent. Or more simplified, employee first name, employee last name from employee E and dependent D, where the first name and last name are equal. At different times, we'll use something that's referred to as exists. Now, this will allow you to check to see whether or not the result of a query is empty. So essentially, if I'm going to have a separate nested query where I'm going to want to run a query provided that certain information occurs. So select the first name and last name from the employee where, and then the following query. If I get into explicit sets of values, I can get into things like retrieving the social security numbers for all employees who works on projects 1, 2, or 3. So again, very simplified. The social security numbers from the works on table where the project number in is 1, 2, or 3. So I'm very specifically calling out those 3 specific project numbers. Additionally, I can use a contains operator. And the contains operator essentially compares 2 sets of values and is going to return true if one contains all the values in the other set. Think of it as like division from an algebra perspective. So for this query example, I'm going to retrieve the name of each employee who works on all the projects that are controlled by department number 5. So select first name, last name from employee, where the select project number from works on where employee number and manager numbers contains the project number where department number equals 5. Now, in certain projects, you'll see the use of is and is not. SQL uses is and is not to compare nulls, but it considers each null to be a value distinct from other nulls. So if I want to pull the names of employees who do not have a supervisor, I'm going to be selecting the first name and last name from employee where the salesperson is null. It means that there's no value in that specific component. However, if a join condition specifies rows with null values for the join are not included in the result. It's one of the things that you really need to make sure that you're looking at. Coming back to joins, if I'm going to look at selecting first name, last name from employee and from supervisor where the employee and supervisor's social security number are the same, it can be written separately. So this is a good example of a left outer join. I don't spend a lot of time on outer joins, but I want to make sure that you're familiar with these. Similar to how you're going to be doing a join and a join on to show not only doing the join but then also providing additional conditions. So both A and B are different options. Now in SQL 2 or PL SQL, I wanted to show a little bit of a deeper understanding. So for every project located in Stafford, we're going to list the project number, the controlling department number, and the department manager's last name, address, and birthday. So I've got multiple joins because I'm pulling from multiple different informations, and this is what the SQL looks like. Now mind you, this is a little bit more complicated SQL than you're going to be asked to write, and more just showing the different things that you can do in terms of the expressions that you can add together. The one thing I want to make sure you don't forget is all the aggregate functions that we can use from a querying perspective. The most common being count, sum, max, min, and average. So if I wanted to find the maximum salary, the minimum salary, and the average salary among all employees, this is what the SQL would look like. select max salary, min salary, average salary from employee. Please note that these are great examples for exams, and I'm going to keep saying great examples for exams in terms of me giving you what the SQL is and doing the reverse. So I may show select max salary, min salary, average salary from employee, and then ask you to select from a multiple choice what this SQL statement does. Looking at query 11, similar objective, find the maximum salary, the minimum salary, and the average salary among employees who work for the research department. This can be done by including the functions in the select statement. So I'm doing the select max, select min, and select average, and then doing my from as well as my conditional expressions. Once I have those results, I'll be entering information into a group by. Group by essentially is a clause that helps specify how you're going to group the attributes, but you must also see that in the select clause. So continuing down this route, if I'm looking at query 12, for each department, retrieve the department number, the number of employees in the department, and their average salary. As you see this, I'm putting in the aggregate functions. So I'm doing the department number, the count, as well as the average, and I'm grouping by the department number. So you'll always see after the from the group by. Now, as another example, for each project, retrieve the project number, project name, and number of employees who work on that project. I'm going to be putting information, and I'm going to be doing multiple conditions from a group by. So where this one, I'm pulling the project number, name, and count from two separate tables, where condition, project number equals P&O, is met, and then grouping after the condition. So you're going to be doing the grouping after the conditions when you're looking at the expressions. You can also use a having clause. Now, the having clause is used to specify a selection condition on groups rather than individual rows. So for each project on which more than 2 employees work, I'm going to want to have the project number, project name, and the number of employees who work on that project. This is a very common query for me because I'm going to want to see which projects require larger staff. So this is allowing me to get the project number and name and count from the two tables, where the project number in the equals P&O and the group by, and then also having. So I'm getting the group by, and I'm going to then further down that is going to be having more than 2. So if I'm looking at an overall summary from a high-level SQL querying perspective, please note a query in SQL can consist of up to 6 clauses, but only the first 2 are mandatory. Repeat. A query in SQL can consist of up to 6 clauses, but only the first 2 are mandatory. You need to know that they're always going to be in the following order: select, from, where, group by, having, order by. If you see these all together, these are the order in which they will be received. Select from an attribute list, from the table list, where the conditions apply, group by your grouping attributes, having group conditions, and order by the attribute list. So you're going to need to know this. So if you're seeing all 6, it's select, from, where, group by, having, and order by. Some more hints. The select clause lists the attributes or functions to be retrieved. The from clause will always specify all relations needed in the query. Okay, make sure that you're realizing that, because then the where clause is going to specify the conditions. Group, as I mentioned, is going to specify how you are going to group. Having is going to be then an additional condition for the selection of the groups. Order is going to order by specifically looking at how you're going to display the results. Now, you always have to make sure the query is going to be evaluated by first applying the where clause. So select from where, and group by, having, and finally the select clause. So if we were looking at some more complex from a SQL Server perspective, you'll see select list into a new table, from, where, group by, having, and order by. And these again are just examples of some more complex statements, not for today's lecture. Also, please remember, and this slide is key, and on the exam related to the different types of aggregate functions. An average is the average of the values in the numeric expression. Count is the number of selected rows. Max is the highest value in the expression. Min is the lowest value in the expression. The STDEV is statistical standard deviation for all values. The STDEV-P is the statistical standard deviation for the population. Sum, total of the values in the numeric expression. var is statistical variance in all values, and varp is the statistical variance for all the population in terms of values in the expressions. This concludes our virtual lecture on writing SQL queries. Thank you.